Hi, I'm Ashley, and this summer I spent my time forecasting and simulating electricity rates. The bottom line up front is that I'm trying to aim how factors such as changes to customer base, consumer use patterns, or fuel prices affect the delivered cost of electricity for residents in Fairbanks, North Scarborough. So I've done this by creating and training stats and ML models, more specifically models called SREMA, SREMAX, and LSTM. My research methods, first was just like a sprawl, like a literature review of GitHub and Kaggle. So I just looked for reports that did similar things that I did. Okay, I'm going to take inspiration from that. Next was data collection. So I kind of collected all of this from the EIA 923, but also I looked into GVEA's like records, their website, more specifically like Ada Creek, because some of that was not in the EIA. And the last part was interpreting and expert review. So I went a lot of times to people for help, like, oh, why is my data saying this? Or like, what does this mean? Can you help me, like, walk me through it? So I'm going to go more into the models I use. So the first one is SREMA. It stands for Seasonal Autoregressive Integrated Moving Average. It's a very widely used stats model for time series data. It's used a lot for like econ, finance, and yeah. And that's the SREMAX. It's the same thing, but it just includes exogenous variables. When you think of exogenous variables, they're like other variables that can help predict what you're trying to predict. And the last one was LSTM. It's a type of recurrent neural network that is designed to model and forecast sequences with long-term dependencies. So this is really good for time series data, where it is sequential. This is the first elementary data analysis I did. It was plotting effective fuel and utility rates. So as you can see, fuel prices are the most volatile. Utility is really stable because you have the definitions up there. Fuel is kind of like more dependent on outside factors like, oh, like how much is natural gas going to cost this quarter, stuff like that. And I'm going to talk really briefly about the spike in 2012. So I'm using real rates. So I adjusted for inflation and I used the base year 2009. So 2012 was when deflation occurred, but prices continued to rise. So with my first two models, the first step was to difference the model if necessary. So one of the main assumptions of these is that mean variance and covariance are like constant over time. And I did a hypothesis test and it came out insignificant, so I did have to difference it. So that just means taking consecutive time points and getting the difference so everything is a bit more normalized. The next two steps are kind of line in line. So they're ACEP and PACEP plotting. So this is autocorrelation and partial autocorrelation plotting, as well as AIC/BIC, which are just like information criteria to help me determine what parameters to use for my model. Next is for the X part, exogenous variable processing. So it's kind of like I also needed to forecast my exogenous variables. And for that, I just took like a simple moving average of mine. So just to preface, my exogenous variables are like fuel prices, natural gas, oil, and also generation by coal, wind, and oil. Yeah. So then lastly, the step is the forecast. This is my first model. It predicted around 27 cents a kilowatt hour. And my RMSE is 0.026. So that's just like a metric to determine how well your predicted points are around the actual point. So the lower the better. Next is SREMAX. So now it went up to around 30 cents a kilowatt hour for the next quarter. And this is an increase from before due to projected increases in oil and natural gas prices. So with exogenous variable forecasting, I'm like able to kind of adjust it due to like, so this is what the EIA predicts in prices for oil and natural gas. So I was able to incorporate it into the model. And the RMSE is lower, so it's performing better with all these exogenous variables being included in it. This is for the LSTM. The steps first was to scale the data. So I had data of all different units. So I had like dollars, kilowatt hours, etc. And so I kind of had to scale the data so it's all within the same range, 0 to 1. And then next is the feature engineer. So I included a rolling statistic of percentage change of effective rates. And then next is to reshape and sequence. So it's just basically to be able to feed into the model. And lastly, train, validate, test, tune the model, check the metrics, and forecast. So this is what I got. Expected around 26 cents a kilowatt hour. And these are nominal rates as well. So I basically put them back into like the prices that we would expect. And then I did not adjust for expected increases in price. This is for oil and natural gas. I didn't really quite get around to that, but the RMSE, the metric is okay. It's around 0.015. And now, scenario simulate. Hopefully this link works. Just need a quick website. Okay. So I was able, this is like all my data, essentially. Like, see all these different scenarios. Drop down menu. So first, I'm going to go over the baseline model. So this is the no scenarios. This is the Siri Max model I was talking about. Then next is what if generation doubles? As you can see, it goes down to around 27 cents per kilowatt hour, which is not that much, but I'm going to go over that. So one, if generation were to double, then these fixed utility costs would be spread over twice as many kilowatt hour sales. So you can see that decrease, but also like it's not decreasing that much. And I think it's because this model is trained on historical data. And according to historical data, when generation spikes, it's probably like, oh, we need to purchase a lot more fuel, which will drive fuel costs up. So I think those two factors are kind of colluding and resulting in this price. Next is, what if natural gas prices double? So this is like obvious, like it's like electricity rates are very dependent on the cost of fuel. So if it were to double, this would happen. What if the mines close? So the mines are the most substantial portion of load on the rail belt. So then if they were to close, you kind of like see the opposite of what happened when generation doubled. Like these utility costs would be spread over like half as many users, and so like each consumer burden will like go higher essentially. These here just in case my website didn't work, but it did. My limitations. I use EIA data, which was I wouldn't say unreliable, but there were some discrepancies, like 2023 to present when data was not present there, and so I was like, oh, that doesn't make sense. So I had to go back to the GBEA like Ava Creek website, and then when I was comparing like the generation, they weren't really matching up. But I was like, you know what, it's okay. Also, natural gas and hydropower are not reported on the EIA or anywhere that I could find, maybe somewhere else. Second is that data resolution is kind of large, so I was using quarterly data, and for especially for like machine learning models, you want to have as much data to feed into these so it can learn better. And third, these models are not suited for long-term forecasting. So it's best to limit to around 1 to 2 quarters. Yeah. Bigger picture is it just gave me and also potentially other people a better understanding of how future scenarios could impact pricing positively or negatively. As the cost of power is a major concern to residents with expected shortages in Cook Inlet as well as sharp increases to around 30 cents a kilowatt hour. This is an issue that is going to probably persist for a while. Lessons learned. Data will take a lot of time to understand. I went to a lot of people, I'm like, I don't understand this, can you help me? I literally just got off a call with Gwen. I was like, hey, can you like rephrase this for me? Like, I don't really know. And then it kind of goes hand in hand with the second. It's like always consult someone for a review and ask for help. Like I have trouble asking questions. So yeah. Conclusion, I successfully modeled and scenario simulated and playing around with like ML and stats packages on Python. I also, the part I really enjoyed was like playing around with simulations, like, oh, what would affect this? Or what would affect like electricity prices the most? As well as like learning from like energy expert about like the energy landscape of Alaska. Thing I did not like was data collection. It was really time consuming trying to scrape together everything I needed. And then if someone were to continue, probably get COPA data, like incorporate that, and also just like familiarize with it because it'll probably give you a better picture of what like electricity prices are like contingent on. Yeah.
What is COPA data?
Honestly, I forgot the acronym, but if the audience knows.
Cost of power adjustment. Cost of power adjustment.
Yeah, she said, yeah.
Sometimes it's called COFA too, cost of fuel.
Okay.
And that's what it is in our system.
I have a question about the hydropower and the gas.
Yeah.
Were you just looking at GBA because we don't have any hydropower, like GBA doesn't operate any dams. We would get our hydropower up the rail belt. And I think natural gas is the same.
Yeah, we don't have any natural gas generators.
Yeah, so we would be getting that as a, what do you
Yeah.
call it when it comes in?
When they buy it,
Power purchase.
Power purchase.
Yeah.
Power purchase.
I think like some places supposed to include like the power they purchase, but I wasn't able to find it. Like it's supposed to be included in that, but maybe they aren't needed to, I'm not sure. I was just unable to find it. Yeah.
It's probably under interchange, because it's
Yeah.
power that's bought off the intertie.
Yeah.
Yeah, if you
It's
go
also,
like, I think the GPA, oh, go ahead.
it's just also not as frequent as people think it is, so there's that.
I think if you go to the GBA website and there's like a pie chart of our generation mix, and they actually include what comes with the intertie. So
Yeah.
it shows that we consume like 35% natural gas or something.
Yeah.
It's ridiculous because we don't consume any, but it's
That's a big
data.
portion missing.
Yeah.
Okay, thank you.